Binary logistic regression with binary predictor in JAMOVI. Binary logistic regression is a statistical techniques or method or test that can be used to find out whether there is an association or a relationship between two variables. One of the variable is called outcome, or it is called response or dependent variable, and the second variable is the predictor, or it can be called the explanatory or the exposure or the independent variable. The aim of this logistic regression test, the binary logistic regression test, is to find out whether the predictor can predict the outcome and whether the variation in the outcome can be explained by the predictor. To use this test, the outcome has to be binary. A binary variable is a variable that consists of only two levels, such as yes or no, have diabetes, no diabetes, have heart diseases, no heart diseases. So the outcome has to be binary to perform binary logistic regression. However, the predictor can be continuous, can be binary, can be multinomial, or it can be ordinal variable. A binary predictor, again, is a predictor or a variable that have two levels in it, such as gender, male or females. Here in JAMOVI data sheet, I had inserted 100 cases, and there are two variables. The first variable is the gender and have two levels in it, males and females. And a second variable, which is the heart diseases, whether you have heart diseases or no heart diseases. So the sex here variable is a binary variable, and the heart disease is also a binary variable. But the heart diseases here is an outcome, as we want to find out what is the chance of developing heart diseases. So here we have one outcome, which is binary, and predictor, which is again binary, as it has two levels in it. So these two variables are both binary. To find out whether there is association between gender and possibility of developing heart diseases, or whether one of the sex have higher probability or higher chances or higher likelihood of developing heart diseases than the other, then the best test to go for is binary logistic regression. Before we perform and do the test, let's look at some descriptive statistics by clicking on exploration, select on descriptive, and then let's drag the sex to the box of variables and the heart diseases into the box of variables, and then tick on the frequency table here, and from statistics we'll remove the median and the mean, as both variable are categorical, i.e. binary, has two levels in it. We don't need the standard deviation, no need for minimum and maximum. So looking at the output from the descriptive statistics here, the first table shows that there are 100 cases. There is no missing cases for any variable. This is a good sign. For the frequencies, it shows that there are more females than males. 52% are females and 48% are males. For heart diseases, there are more heart diseases cases than non-heart diseases. 56% of cases have heart diseases and 44% don't have heart diseases. To perform binary logistic regression, click on regression here and then select two outcomes binomial for regression. If this function is not available here in the menu, click on the module here and then add that through the JAMOVI library. So back again to regression, click on outcome for binomial regression. A new window is generated. Here we can see that we have two variables. We'll move the outcome, which is the dependent variable, into the dependent variable, and 6 we will move it into the factor here. Since it is binary, let's select some options from the list here. For model builder, nothing to choose from. For the reference levels, since we have two variables, both variables are binary. For the heart diseases, the no heart diseases will be the reference category to compare to, and for the 6 variable, the females will be set as a reference category, and the males will be compared to females. For the assumption checks, no, we'll not look at it at this stage. For model fit, take on the Cox Snell R Square and the other R Square. For the model coefficient, take on the odds ratio and the 95% confidence interval. Looking at the output from the JAMOVI section here, there are multiple tables. The first table is the model fit measures. Looking at the R square value here, which is 0.735, this R square means that 73.5% of the variation in the outcome, which is the heart diseases, can be explained by the predictor, which is the sex or the gender of the individual. This is a high value. Moving to the second table, which is the model coefficient for, again here, heart diseases. So we are here looking at heart diseases, and that's what we will interpret from this table. For the predictor section, males to females. Again, the females will be the reference group here, so male will be compared to females. The estimate, which is the coefficient, is given here, the standard error, the z-score, the p-value, the odds ratio, and the 95% confidence interval for the odds ratio. So here we have two levels of determining whether there is significance or not. P-value, if it is less than 0.05, then it is significant. And the 95% confidence interval, in which the odds ratio should fit between the lower and the upper limits for that confidence interval. From this table, it is well shown that there is a significant association between the gender and probability or possibility or likelihood of developing heart diseases, as the p-value is significant and the odds ratio fell between the 95% confidence interval. So essentially, yes, there is this test will answer the question, yes, there is association between individual gender and the probability of getting heart diseases or the odds of hitting heart diseases. The way to interpret this table is that males have a higher probability or likelihood of getting heart diseases than females, and this probability is significant. In another way, males are more likely to develop heart diseases than females, with an odds ratio of 224.5. So from this table, males having a higher likelihood or probability of developing heart diseases. So this is the way to perform binary logistic regression in JAMOVI with a predictor that is binary, that is made up of or consists of two categories. If you find this video useful, do subscribe to the channel, leave any comment in the indicated box, and activate the notification bell to receive the recent and latest release into the channel of several different video clip, and click on the like icon and share the video link with others so the channel can expand and improve to include a large scope of different statistical method and how to analyze data using several different statistical packages such as SPSS, Excel, Stata, JAMOVI, R Statistics, GraphPad, Prism, GPower, Python, and RevMan. If you are a student or a researcher and you have a data, whether it is quantitative or qualitative, and you want to perform statistical analysis on that data using any of the softwares listed here, whether it's SPSS, Excel, Stata, JAMOVI, R Statistics, GraphPad, Prism, RevMan, GMP, Python, then do contact me to arrange for either a one-to-one private tutor session or a training course on any of these statistical packages. My contact details are given here, so don't hesitate to write to me or email me if you need a private one-to-one tutoring or a training course.